A Chinese smartphone company just pulled off something nobody saw coming. They built a car that's beating some of the world's most expensive hypercars, and not by a tiny gap either. We're talking about numbers so wild that engineers in Germany, Italy, and England are sitting there staring at data sheets like, how did a tech brand crack something car companies spent decades chasing? That question is making a lot of big names uncomfortable right now. And the craziest part, this machine doesn't even look built for racing. There's no giant rear wing hanging off the back, no sharp splitter scraping the road, no crazy race car add-ons anywhere. From far away, it almost looks unreal, like somebody turned a single drop of water into a futuristic supercar shape. Smooth lines, clean bodywork, and airflow tricks that break away from what traditional car makers have been doing for years. The car is called the Xiaomi Vision GT, and when it showed up at the 2026 Beijing Auto Show, people didn't just stop and stare. Veteran automotive engineers were left questioning everything they thought they understood about grip, aerodynamics, and high-speed performance. This thing walked in and flipped the whole conversation upside down. But to really understand why this car has the auto industry shook, you've got to go back to the basics. The story of the rear wing is tied to one of the oldest and most stubborn problems in car history, and this battle started way earlier than most people realize. For decades, the rear wing was the go-to fix for one major issue. When cars hit insane speeds, the airflow tries to lift them off the road. Not like a plane taking off, but close enough to become dangerous, and air moving across the body creates lift, which reduces how much the tires stay planted on the pavement. Less tire contact means less grip, and at 150 miles per hour, losing grip turns a driver from being in control to hanging on for dear life. That's where the rear wing changed everything. Instead of lifting the car like an airplane wing, it pushes the back of the car downward. Engineers call this down force. More pressure on the tires means more grip, sharper cornering, and better control at crazy speeds. That sounds simple, right? Clean solution, huge results, and for years it became the secret weapon of high-performance cars everywhere. But here's the catch nobody talks about enough. Rear wings solve one problem while quietly creating another, and that trade-off has frustrated engineers for decades. Every time a rear wing pushes a car down onto the road, it's also fighting against the air at the same time. That creates drag, and drag is basically the silent killer of speed. It's the same force you feel when you stick your hand out of a moving car window and the wind yanks it backward. The bigger the wing gets, the more downforce it creates, but that also means more drag slowing the car down. That's the brutal trade-off engineers have been stuck with for decades. You can't fully max out both sides. More grip usually means less straight line speed, and less drag usually means less control in corners. So car companies have spent years trying to chase the perfect balance between planting the car to the ground and cutting clean through the air like a blade. This isn't some tiny side project either. Racing teams hire entire groups of engineers whose only job is finding microscopic aerodynamic gains. They spend thousands of hours in wind tunnels chasing improvements so small, most people would never even notice them. Sometimes a fraction of a second is the difference between losing and winning championships. That's how serious this game gets. Every curve, vent, and body panel is designed to control airflow with insane precision. And sitting right in the middle of all this is the biggest question in performance engineering: more downforce or less drag? The best European hypercars today reach what engineers call an aerodynamic efficiency ratio of around 3.0. In simple terms, for every unit of drag they create, they produce about 3 units of downforce. That number took over 50 years of motorsport experience, massive research budgets, and some of the smartest automotive minds on the planet to achieve. 3.0 was supposed to be the limit. That number became the gold standard in the hypercar world. The benchmark engineers chased for years without being able to push past it. Most experts believed nobody could beat it without completely changing the way cars were designed. Then Xiaomi showed up and shattered that idea with a jaw-dropping aerodynamic ratio of 4.1. Let that sink in for a second. A company that started out selling affordable smartphones back in 2011 just stepped into one of the toughest engineering battles on earth and dropped a number that many people thought was flat out impossible. But the wildest part isn't just the number, it's where the inspiration came from. Xiaomi didn't study old race cars or copy traditional supercar makers. They looked somewhere completely different. They looked to the sky. The secret behind the Xiaomi Vision GT actually comes from stealth bombers, not sports cars. Think about aircraft like the B-2 bomber. The first thing you notice is how strange it looks. No giant tail fins, no bulky stabilizer sticking out everywhere, none of the shapes people normally expect from an airplane. It almost looks like a giant flying blade or a manta ray gliding through water, smooth, clean, silent looking, and built with a totally different philosophy from normal aircraft. And here's the key part, that shape wasn't created just to look futuristic. Every curve and surface exists for one reason, controlling airflow in ways traditional designs simply can't. This wasn't about flashy styling or trying to look futuristic for attention. It all comes down to pure physics. Stealth bombers are designed so the entire body controls airflow without needing extra external parts hanging off the aircraft. Instead of relying on separate structures, the shape itself creates the aerodynamic forces needed to fly. In aerospace engineering, that idea is called a lifting body. And the Xiaomi's engineers looked at that concept and asked a bold question that changed everything. What if you flip the whole idea upside down? Instead of designing a body that creates lift like an airplane, what if you built one that creates the exact opposite? What if every curve, every surface, and every angle worked together to force the car toward the ground? Not with giant wings or race car add-ons, but through the body itself. That idea became the foundation of the Xiaomi Vision GT. Engineers call it a reverse lifting body design, and it's the secret sauce behind this machine's insane performance numbers. The layout of the car is completely different from traditional supercars. The cockpit is physically separated from the front and rear sections of the chassis, making the cabin look almost like it's floating between both ends of the car. And that unusual setup isn't just for looks. It creates narrow airflow channels underneath the vehicle that work like high-speed tunnels. As air rushes through those tight spaces, it speeds up dramatically, which lowers the pressure underneath the car. At the same time, pressure above the car stays higher. That pressure difference creates an enormous suction effect that pulls the vehicle toward the road at high speed. That's the game-changing part right there. Traditional supercars rely on giant wings to push the car downward. The Vision GT doesn't need that. The entire body becomes the downforce system, turning the car itself into one giant aerodynamic weapon. Think about holding two pieces of paper close together and blowing air between them. Most people expect the papers to push apart, but instead they pull toward each other. That's the Bernoulli effect. And it's the exact same physics happening underneath the Xiaomi Vision GT at over 200 miles per hour. As air blasts through those narrow channels under the car, it speeds up fast, pressure drops, and the suction force becomes insanely strong. The faster the airflow moves, the harder the car gets pulled down onto the road. And this is where the design becomes a total game changer. Traditional rear wings create downforce, but they also create heavy drag that fights against speed. Xiaomi's setup works differently. Instead of blocking the airflow, the body guides it smoothly and efficiently. The car cuts through the air while using that same airflow to generate massive grip at the same time. No oversized wing, no huge drag penalty, just raw physics working through the shape of the car itself. Once you understand that idea, the smaller engineering details packed into this machine start looking even crazier, because creating downforce through body design alone sounds brilliant, but it also creates a whole new challenge engineers had to solve. Here's where things get even wilder. When a car attacks corners at extreme speed, air smashing into the sides of the vehicle can disrupt the airflow underneath it. And if that airflow gets unstable for even a moment, the car can lose grip exactly when the driver needs it most. That's the problem Xiaomi's engineers had to tackle next, and the solution shocked a lot of people in the industry. If that carefully designed low pressure zone underneath the car gets disrupted even a little bit, the grip can vanish instantly. And at 150 miles per hour, the difference between perfect control and total chaos happens in milliseconds. That meant Xiaomi had to fix a huge problem created by their own wingless design, and the solution they came up with is seriously clever. The company borrowed an idea straight from Le Mans prototype race cars, a vertical fin running down the center of the vehicle. It works almost like the keel on a sailboat. Its job is to keep airflow stable and organized, even when strong crosswinds slam into the sides of the car during high-speed cornering. Without that fin, the airflow underneath could become chaotic every time the car turned hard, which would destroy the downforce balance in an instant. But with the fin in place, the air stays controlled and locked onto its intended path, keeping grip stable even at extreme speeds. And Xiaomi didn't stop there. Hidden inside the rear taillight section is an advanced system filled with tiny air pores that push airflow outward in carefully controlled patterns. That setup creates what's basically an invisible air shield around the back of the car, The goal is to stop turbulence from sneaking in and disrupting the low pressure zone underneath. In simple terms, the car is actively protecting its own grip while moving at insane speeds, and that's the kind of engineering that's got the auto world talking. This is the kind of advanced aerodynamic tech that professional racing teams spend years trying to perfect, but Xiaomi quietly packed it into a concept car and blended it into the design so smoothly that most people would never even notice it at first glance. That's what makes this thing so crazy. The engineering is hidden in plain sight. Even the wheels are pulling double duty. At first they look like they have transparent aero covers similar to the discs seen on endurance race cars. Pretty cool already, right? But when you look closer, the inside structure has a gear-like shape built into it. And once those wheels start spinning, that shape works like a fan system. As the wheel rotates, it pulls cool air inward toward the brake rotors while forcing hot air back out. That keeps the brakes from overheating without messing up the airflow around the outside of the wheel. So the wheel isn't just spinning, it's actively helping with cooling and aerodynamics at the exact same time. That's two massive jobs handled by a single component with almost zero compromise. Most car companies struggle to perfect even one of those systems. Xiaomi somehow combined both into one passive design without needing extra motors, bulky electronics, or complicated moving parts. And that's what separates the Vision GT from traditional supercars. Every single part of this vehicle is connected to the same mission: the body shape, the center fin, the hidden airflow pores, the wheels. All of it works together like one giant system focused on creating smooth, stable, high-speed grip without relying on a massive rear wing. That level of integration is what has engineers paying very close attention right now. This level of detail says a lot about the people behind this project. These aren't engineers who accidentally stumbled into good aerodynamics. Xiaomi's team approached this car with the kind of big picture systems thinking normally seen in aerospace programs, not traditional row cars. Every piece was designed to work together with a purpose, and that's why the Vision GT feels so different from the usual supercar formula. But here's the thing, insane aerodynamics alone don't make a car great. A vehicle can be lightning fast, but if the structure can't handle brutal cornering forces or protect the driver during an impact, then all that speed means nothing. Real engineering isn't just about going fast, it's about building something strong enough to survive the pressure that comes with those speeds. And this is where Xiaomi's SU7 Ultra architecture becomes just as important as the Vision GT's airflow tricks, because what they built into the core structure of this car is seriously impressive. Most production cars, even expensive luxury models, rely on what's called a single path or dual path crash structure. In simple terms, when the vehicle crashes, impact energy travels through a limited number of structural channels before being absorbed by crumple zones. That setup works well enough to pass modern safety standards, but there's still a limitation. During extremely high-speed impacts or awkward crash angles, those channels can become overloaded. When that happens, energy doesn't spread out quickly enough, and more force can make its way toward the cabin area. Xiaomi tackled that problem with a much more advanced structural approach. And it's one of the biggest reasons engineers started taking this project seriously instead of dismissing it as just another flashy concept car. That's the exact moment when a crash can go from survivable to extremely dangerous, and Xiaomi knew that if they wanted this car taken seriously, they couldn't rely on old school safety engineering. So with the SU7 Ultra platform, they designed a structure that spreads crash forces in a completely different way. Instead of using one or two main impact routes like most vehicles, the SU7 Ultra uses 3 separate load paths working at the same time. When the front of the car takes a hit, the crash energy instantly splits in 3 directions: upward through the front shock towers, straight back through the main structural beams, and downward into the subframe beneath the car. That's a huge deal because the force gets broken apart before it can concentrate and slam into the passenger cabin. Instead of one section trying to absorb everything alone, the energy is spread across multiple routes simultaneously, reducing the amount of stress reaching any single area. It's a much smarter way of handling violent impacts at high speeds. But the material holding this whole structure together is where things become truly shocking. Xiaomi used ultra high strength steel rated at 2,200 megapascals. To put that into perspective, most high-strength steel used in regular car frames sits around 500 to 600 megapascals. Even the structural steel used in skyscrapers is usually around 250 megapascals. That means the steel protecting this cabin is massively stronger than what most people would expect in a production vehicle. The door pillars, roof rails, and the main cabin frame are all built using this material, connected together with seamless heat-treated tubing that forms one continuous safety cage around the occupants. The end result isn't just a structure designed to pass standard crash tests. Xiaomi engineered this thing to handle impacts at speeds roughly 20% higher than typical global safety requirements, and that's the kind of overbuilding that caught the industry off guard. And here's why those numbers matter way more than most people realize. In physics, crash energy doesn't increase in a straight line with speed, it increases exponentially. So if impact speed goes up by 20%, the chassis doesn't just deal with 20% more force, it has to absorb over 40% more energy. That's a massive jump in stress, and yet this structure is built to handle it while keeping the passenger cabin stable and intact. That means the cabin geometry holds its shape during severe impacts. The roof stays strong, the doors are designed to still function, and the protective safety cage helps preserve survival space for the people inside. Achieving that level of structural strength in a high-performance electric car is already impressive enough on its own. But what Xiaomi engineered underneath the vehicle could end up being even more important for the future of EV safety, because when it comes to electric vehicles, the battery pack is both the biggest advantage and the biggest risk. Modern lithium battery packs store enormous amounts of energy. Under normal conditions, that energy powers the motors in a smooth and controlled way. But if the battery pack gets seriously damaged, like from major road debris or a severe crash at highway speed, things can become dangerous very quickly. Inside the battery cells, temperatures can rise to extreme levels within seconds. Once certain chemical reactions begin, they can feed themselves continuously, creating a chain reaction known as thermal runaway. And that's what makes EV battery fires so difficult to control compared to normal vehicle fires. Traditional firefighting methods often struggle to stop the reaction completely, which is why some EV fires can continue burning for a very long time after the initial impact. That's the challenge Xiaomi's engineers knew they had to solve if they wanted this car to compete with the best in the world. Most automakers have tried solving battery protection by adding thicker aluminum plates underneath the pack. On paper, it makes sense. Thicker armor gives better protection against punctures and impacts from road debris, but there's a major downside that comes with it: weight. And in an electric vehicle, extra weight creates problems everywhere else. More weight means shorter driving range, slower acceleration, reduced efficiency, and more stress on the suspension, brakes, and tires. So while you're fixing one issue, you're also making the car heavier and less efficient at the same time. That trade-off has frustrated EV engineers for years. Xiaomi looked at the problem and decided the usual solution wasn't enough. Instead of relying on just one protective layer, they attacked the issue from 3 different angles all at once. First, the battery pack is surrounded by a honeycomb-style aluminum structure designed specifically to absorb impacts from underneath the car. Think of it like a crumple zone built for the battery itself. During a side or underside collision, that structure is meant to crush and sacrifice itself first, soaking up energy before it can reach the battery cells. Second, Xiaomi added a massive protective beam near the front section of the undercarriage. Its job is to intercept dangerous road debris before it can shoot backward underneath the vehicle. If something like metal fragments or sharp rocks gets kicked up at high speed, that beam is designed to break or deflect the object before it reaches the battery pack. But the most impressive part of the whole system isn't the armor or the support beams, it's the special material coating the bottom of the battery pack itself, and that's where Xiaomi's engineers really surprise people in the industry. Most electric vehicles use fairly standard protective coatings underneath the battery pack, mainly designed to handle moisture, dirt, and everyday road damage. Those coatings work fine for normal driving, but Xiaomi took things way further with the SU7. They developed a proprietary ballistic-grade resin coating, the same category of material technology often associated with high-impact protective systems. And this wasn't just marketing hype either. During direct puncture tests using high-speed steel spikes, the battery structure reportedly stayed intact. Even more impressive, engineers pushed the system through forced failure testing in freezing sub-zero conditions, where the battery cells were deliberately stressed to extreme limits. In those tests, the thermal management system automatically redirected and vented heat in a controlled way. No uncontrolled fire, no explosion, and no catastrophic chain reaction. Instead, the system managed the failure on its own while keeping the situation contained. That's a massive deal in the EV world, especially considering how difficult thermal runaway can be to control once it starts. At that point, Xiaomi wasn't just building a fast electric car anymore. They had essentially created a heavily protected energy system underneath a high-performance vehicle. Combine that with the ultra-strong safety cage above it and the advanced aerodynamics surrounding the entire chassis, and you start seeing the full picture of how deeply engineered this machine really is. This car wasn't designed only to chase speed numbers, it was engineered to handle speed, pressure, impacts, and extreme conditions all at once. And once you see what it did on a real racetrack, the entire industry reaction suddenly starts making a lot more sense. After hearing all of that engineering talk, there's really only one question left: does this thing actually deliver on a real racetrack? Because flashy concepts and wild tech claims mean nothing if the car can't perform when the pressure is on. And there's no tougher proving ground than the Nürburgring Nordschleife in Germany. This legendary track stretches over 20.8 kilometers and is considered one of the most brutal circuits on Earth. It has more than 170 corners, massive elevation changes, blind turns, uneven pavement, and sections so narrow that two cars barely fit side by side. The track cuts through a forest too, which means temperatures and grip levels constantly change as sunlight disappears in and out through the trees. Drivers call it unforgiving for a reason. For decades, the Nürburgring has been the ultimate test for performance cars. Automakers from all over the world use lap times there as proof that their engineering is real and not just hype. If a car can dominate the Nordschleife, people take it seriously, and that's where Xiaomi shocked the industry. The production version of the SU7 Ultra, the actual version customers can buy, completed the Nürburgring lap in 7 minutes and 4.957 seconds. That officially made it the fastest production electric vehicle ever recorded on the track at the time. It even beat the Rimac Nevera, a hypercar built specifically to chase EV speed records, by more than 0.3 of a second. But Xiaomi didn't stop there. A prototype version of the SU7 Ultra pushed the limits even harder and recorded a staggering lap time of 6 minutes and 22.091 seconds. At the time, that placed the Xiaomi prototype as the third fastest car ever recorded around the entire Nordschleife, putting a smartphone company right next to some of the biggest legends in automotive history. Third place. Think about how insane that sounds for a second. In the entire history of the Nürburgring, one of the most legendary and difficult racetracks ever built, a car from a company that was mainly known for smartphones just 15 years ago ended up on the same leaderboard as purpose-built racing monsters worth millions of dollars. Some of those machines aren't even legal to drive on public roads, yet Xiaomi's name landed right there beside them. That completely changed how people viewed the company overnight. And now, to keep things fair and accurate, there's an important detail about the Vision GT itself. Xiaomi confirmed that the car was created together with Sony as part of the Gran Turismo 7 Vision GT project, where manufacturers designed futuristic dream cars specifically for the game world. So no, this exact vehicle is not heading into dealerships, and you won't be able to buy one in real life. There's also another important point worth being clear about. The massive 4.1 aerodynamic efficiency ratio comes from advanced computer simulations rather than a full real-world wind tunnel validation. And that distinction matters. Simulations today are incredibly advanced and extremely useful, but they still aren't identical to testing a physical car against real airflow at full speed. But here's why the auto industry still paid attention anyway. The Vision GT wasn't just built as a flashy digital concept, it was a statement of engineering direction. It showed exactly how Xiaomi's team thinks, what kind of technology they're chasing, and how they believe future performance cars will evolve. And the crazy part is that many of those ideas are already appearing in real-world vehicles people can actually drive. The Nürburgring records set by the SU7 Ultra are real and officially recognized. The advanced safety cage materials are real and have been independently tested. The reinforced battery protection system is real and has gone through extreme durability testing. What Xiaomi proved shocked a lot of people in the automotive world. Building a world-class performance car is no longer something only a handful of century-old manufacturers can do. The knowledge, technology, and engineering talent are spreading fast, and the old guard suddenly has a serious new competitor watching their every move. A completely new type of company has entered the performance car world, and that's what makes this story so wild. Xiaomi didn't come from decades of motorsport history or old racing dynasties. They came from consumer technology, smartphones, software, and electronics. and somehow they walked straight into one of the toughest engineering industries on earth and started changing the conversation. The rear wing isn't disappearing overnight, of course. Plenty of supercars and race machines will still use them for years to come, but the old belief that every insanely fast car must rely on a giant wing to create grip, that idea just took a serious hit. The engineering philosophy behind the Vision GT, combined with what the SU7 Ultra already achieved in the real world, shows that performance car design is entering a completely different era. And honestly, the next few years are going to be crazy to watch. We're talking about new technology, new ideas, and new companies pushing boundaries in the ways the auto industry hasn't seen before. The competition is only getting started, and the established giants now know they've got a serious challenger on the scene. If this blew your mind too, make sure to like, share, and subscribe to the channel so you don't miss the next video. Turn on notifications as well, because this industry is moving fast and the next breakthrough could drop at any moment. And here's the big question: if Xiaomi actually turns the Vision GT into a real production car 5 years from now, how do you think Germany, England, and Italy respond?